All right. Average rate of change. Average rate of change is something that we need to discuss. It's a very critical part to calculus, but it's pretty elementary. It's pretty simple. You already know it for lines. Okay. Average rate of change for a line, basically saying over a certain interval, how fast is the y value changing? Okay. And for a line, that's the same thing as slope, isn't it? Okay. If I look at this line here and I ask you, how fast is this line changing in regards to its y values over a particular interval? So let's say from like 0 to 1, 2, 3, 4, 5 here. Okay. Looks like at 0, I'm at about 10, 20. Let's just make it easy to do the math, do 30. Okay. And up here, it looks like it's at 50. Does that make sense? And I ask you, how fast is that thing changing over that interval of 0 to 5? Okay. Well, the y values difference is 20, right? Okay. So we've changed a total of 20. Okay. But we've done it over an interval of 5 units, correct? Okay. Let's take 20 divided by 5, and it gives me 4. So on average, every time that I go 1 unit to the right, it's going up 4 units. Does that kind of make sense? Okay. That's average rate of change. That's exactly what you talked about in regards to slope back in algebra 1. Okay. When we see the phrase average rate of change, we are talking about slope when it is a line. Okay. However, when it's not a line, we still do the exact same procedure. Average rate of change is the change in your output, and we see the word change algebraically means difference, right? So you say difference in output divided by difference in input. Okay? And in a science class, maybe you see it written as, you guys know what this Greek symbol is right there? Delta. Okay? So we see it as delta y over delta x, which is again change in y over change in x. Okay? Science, physics, that kind of stuff uses delta. When you get to calculus, we use delta a lot. Okay, so delta y over delta x. That's also equivalent here to that formula, which that formula right there is exactly what? Slope. That is the exact same thing as slope. But now they write it a little bit differently here. Okay? And this one here allows us to apply average rate of change for things that are nonlinear. Okay? And what it's doing is saying you've got 2 x values, x sub 1 and x sub 2. Okay? So subscripts are just to tell us there's a difference between, be able to differentiate which x value I'm looking at. Okay? So like a last name for our variable. So if I have x sub 2, well, this f of x sub 2 is the y value that goes with that x value, right? Well, it's the same idea that we had here, right? Isn't that a y value, y sub 2? Isn't that the y value that went with the x value of x sub 2? Okay, as an ordered pair. So these two things are still, this is still your y value up top, and this is still your x value down bottom for a particular ordered pair on a nonlinear function. And then the same thing over here, that's the ordered pair. There's your x value, and here's your y value. What people try to do is remember it in this order. It doesn't have to be in this order. Just like slope doesn't have to be y2 minus y1 over x2 minus x1. It could be y1 minus y2 over x1 minus x2. Does that make sense? Okay. And what happens, let's say if this total here would have been negative. Let's say the numerator would have been negative there. Okay. Well, if I do it this way with the exact same values, now the denominator is going to be negative. Well, is that okay? Is that still just a negative quantity? It doesn't matter where the negative shows up. It shows up in the top, shows up in the bottom, the entire quotient is still negative. The only thing you got to pay attention to is the ordered. Okay, the ones, the x1, y1, they got to come first. y2, y2 has to come second. Or y2, x2 has to both come first, and then y1, x1 has to come second. Okay, you cannot, and I see this every year, you can't do this. You can't put that as a 2 and that as a 1, because now you've got kind of crossing things up there. And that's going to mess up your signs ultimately. You'll have the same quantity, but if my grade change to be positive, you'll get a negative 1. or if it should be negative, you'll end up getting positive. So just be careful with that. You'll see questions, kind of skip through here to this question. I know I kind of cut this and pasted it out of another textbook, and just the way it was presented in that textbook, it's really hard to get the zoom in so you can see this real well. But it says gasoline costs have experienced some wild fluctuations over the last several decades. Okay, it says table 1 lists the average cost in dollars of a gallon of gasoline for the years 2005 to 2012. So the cost of gasoline can be considered as a function of year. Okay, so depending on what year it is, I can determine how much gas costs. Right? Okay. So gas is a function of year, or price is a function of year. And the way they're doing this, okay, when I read that, the cost of gas is a function of year, okay? Well, that tells me that year is the independent variable. That tells me year is my input value. Does that make sense? So I'm going to have ordered pairs here of Y for a year, and then they're using capital C for cost, and then Y for year. Okay. If you're a person that's more comfortable with like X's and Y's, that's fine. Understand that your X's would be the year, and your Y values would be C of that year. Okay, their cost of that year. Okay. They want us to find the average rate of change between 2007 and 2009. So I look at those two data points, 07 and 09. Okay. In the year 2007, comma, 2.84. Okay, that data point gives me this ordered pair of 2007, comma, $2.84. Okay. This one here gives me the data point 2009, $2.41. Okay. Now, because more than likely this is a nonlinear function. Okay. So this is how I'm going to label these things. This is an x sub 1, okay? And actually, we're using the y's and the c of y. I'm going to say this is y sub 1, and this is the cost at y sub 1. This is y sub 2, and this is the cost at y sub 2. Now, if we do the average rate of change, just in a generic format for these y1, y2, c of y1, c of y2. Okay, the output values go on top. Okay, so I'm going to say c of y2 minus c of y1 all over year 2 minus year 1. So that's output. Okay, and that is your input. And now we're going to do those differences. Okay, so I'm going to go 241 minus 284. And then on the bottom, I'll have 2009 minus 2007. Up top, I get negative 43 cents. On the bottom, I get 2 years. And that works out to be an average. Understand we're taking an average here, right? Okay, seeing how much it fluctuates and divided by how many years that time elapsed. Okay, so we're finding an average using that 2 years here, that's the time. And it gives me negative 0.215 cents. Okay, or sorry, negative there. Negative 21.5 cents. Does that kind of make sense? Okay. So from, if we analyze this and work with this at 2007, if I take $2.84 and I subtract 21.5 cents from that, okay, take that number, subtract 21.5 cents, it should get me an idea of how much gas would have been in 2008. Now, that's not exactly what gas was in 2008. Does that make sense? Okay, it's average rate of change. Even though it fluctuated up, it eventually came back down, and the change from here, if I take 2.84 minus 21.5, okay, or 21.5 cents, gets me 2008. Take away another 21.5 cents, should get me to $2.41. Does that make sense? It makes sense a lot. Okay. But realize that it's average rate of change. So here, we're at like 284. We go up, okay, but then we come back down in 2009, right? Okay. Even though there was an instance in 2008 when we were up here at a high price, this decrease compensated for that. All right, it undid that price hike. Does that make sense? Okay. They do this type of stuff all the time, analyzing stocks and prices of tuition and things like that. Happens all the time, and average rate of change is a very big component to analyzing how markets work and stuff like that. Okay. What we got here? 03? Okay. We'll also see in your just different ways of them presenting questions about average rate of change. You're going to say find the average rate of change on the interval from -1 to 2. Okay? From -1 to 2. So we get that point right there. That's a y value. So that ordered pair is -1, 4. And at 2, that ordered pair is 2, 1, right? That's the interval we're interested in. We don't care about anything else. We're just looking between that value there and that value there on the x-axis. And we're going to analyze the y values on that interval. Okay? So the y values, okay, so maybe now you're a person, let's go, this is x1, and this is f of x1. This is x2, and this is f of x2. Okay? To find the average rate of change then, we're going to take f of x2 minus f of x1 divided by x2 minus x1. Okay, so f of x2 equals 1 minus f of x1, which is 4. On the bottom, x2 is 2. x1 is -1. We end up with it's -3 over 3. And our average rate of change is -1. Okay? What I want you guys to understand, what you realize here is, was that the same thing as slope? And really what we're doing is we're finding the slope of that line, and we say the slope of that line is the average rate of change of the y values on that curve between those 2 points. You guys remember in geometry, if I had a circle and I had a line like that that goes through that line, or through that circle 2 times, but it's a line that continues forever, what that's called? Start with an S. Not sine. Starts with an S-E. Close. Secant. Okay? That's a secant line for that circle. This is referred to as a secant for this curve. Okay? And calculus-wise, what we like to do is be able to determine the slope of a curve at any point. Okay? Knowing that the slope of a line at any point is the same, right? Always, if the slope of a line is 2/3, no matter where I'm at on that line, it's always 2/3. Well, it changes on a curve. Okay? If you're standing right here on that curve, are you at a lesser slope or lesser incline than you would be if you're standing up there? Yeah. Okay? It's just a little bit flatter down here. So that secant line helps us determine the slope of that curve as it changes. Okay? We'll pick up with this again tomorrow.